In this video we'll cover void functions. A void function is a block of statements that takes control of the program, executes a small task, and releases control back to the caller. Now, the statements don't actually take control of the program. Instead, it's the function that takes control of the program. The caller of a function is another function or the main program, and it's usually in the form of a statement. The syntax for defining a function is the keyword def, the function name, and some statements. We're just displaying hello to the screen here. We can run this program, and as you can see, nothing happens. Why? Because this is only a function definition. We define what this function is going to do. In this case, it's just displaying to screen. So let's backtrack. Let's define a function, print hello world. It's going to print hello world. And that's the function definition. If we want the function to execute, we have to call it. In this case, the main program is the caller. The caller calls a function, the function executes, and then releases control back to the caller. It displays hello world, and that's what we wanted, and that's how you would define a void function and call it. When we create functions, we want to keep in mind the program readability. Why? Why do we want to keep in mind program readability? Because if we don't, our functions may get too large, and then it'll be difficult for programmers in the future or even the creator of the program to support it. Thus, functions can call another function. The reason is to encourage keeping our functions to a minimum. I would say one task, and if our function is more than 20 lines of statement, then we probably need to break that function into another function. For example, a function calls another function. We define a function main. This function is going to call a some numbers function. Notice that PyCharm is telling us that some numbers has an issue, and it's telling us that it's not in our program. Thus, we have to define a some numbers function, and we want to just print 3 plus 3 and display it. We've defined two functions. We're going to call main. Main is going to give control. When we call main, the program gives control to the main function, which calls some numbers, releases control to some numbers prints to screen, gives control back to main. Main comes back to the original program, which is really the main program, and then it exits. Let's go ahead and run it. And that's what happened. what we can do to see the execution visually: print, calling main, print, releasing control to caller, print, calling or called some numbers, likewise called main, releasing control to main, which is a caller. Let's run it one more time. Called main, call some numbers display 6. Now releasing control to main, and then releasing control to caller. So that's how our function executes. There we go. Let's close this examples, and now let's talk about variable scope. From the first few lectures, I've stressed that it's important to keep variable scope in mind when we're working with programs. So variables created in a function are only accessible within the function. If you want to access it outside the function, if you use Python idle, you will get an error when you run the program. If we use PyCharm, like we are in this case, then Python is going to alert us that we are trying to access a variable that is not available. So remember, local variables are restricted to the code block where they're created. In this case, our code block is going to be a function. Other cases are loops and if statement code blocks. Let's define a print numbers function. Create the variable 5, and we display it within the function to screen, and then we also want to attempt to display it outside the function. And if you can see here, it's telling us that it's unresolved. If we insist, then Python is going to throw an error, name num is not defined. Building on this example, we can declare a num variable outside the function in the main program's space or domain scope. So we create the variable 10, and notice that now we're not receiving a warning. However, we also want to display the number 5, so we call the function print numbers. We run it, and we display 10 and 5. Why? Because this variable lives outside the function, and we print it here, and then this num lives within the function, and we print it here. Let's drill this concept home. We're going to create yet one more function, and we're going to name it print another number, and we're also going to name it num. We're going to assign it the value 3, and then we want to call the function print another number, and we want to run it. We need to do print num here and run it. Now we get 10, 5, and 3 displayed to screen. which is what we expected because we have three different scopes. We have the main scope, and then we have print number scope, and then we have print another number scope. Notice that if we do this and we run the program, now 10 is displayed 3 different times because functions can access variables that live outside its scope, because this is the parent and this is a child program or domain, and that's why we can do that. So keep that in mind as you're building programs. Our examples so far have not used parameters. Parameters allow us to create flexible functions. What is a parameter? Well, let's create an example because it'll be easier to explain and to visualize. So we create a function square numbers. We say we're gonna have one parameter. This right here is a parameter for a function, and then we're gonna print num squared. We have the function definition here. Now we want to call the function with a number, the number 5. 5 in this case is an argument. 5 is an argument. Num1 is a parameter. We run this program and we get 25 displayed to screen. We call square numbers with an argument of 5. We pass it into the function and then we print it. So when this program runs, num1's value is referencing 5, and then when we print it, it prints 25. It exits back to the main program, and then there's no other statements and the program exits. We can continue to call the same function with different values or similar values, and when we run it, we get 5 squared, 6 squared, 7 squared. I'm going to copy this function. We can also call a function in a loop. For example, here for I in range 3, we want to call square numbers with I plus 1. And we run it, and we get what we expect. The function is going to be called 3 times. The first time the value is 1. Why? Because we said I plus 1, and remember, in loops the index begins at 0. However, we know that and we want to force it to start at 1, so we just add 1. And then 2 squared is 4 and 3 squared is 9. A variable can also be a function. We create the same function definition, square numbers, and instead of passing it the number 5, we assign number 5 to a variable, and then we call square numbers. So now num is an argument. We run the program and it gives us the same result. A function can also have multiple parameters or arguments. This helps increase our program flexibility, and it begins with the function flexibility. For example, say we have a function multiply numbers with parameters num1 and parameters num2, and we want to print num1 times num2 to screen. We call the function with the number 5 and the number 6, and we run it. We call the function and we run it, and we get 30, which is what we've expected. So now we can pass in two different numbers. The final concept I want to cover is arguments. The argument scope. Let me pass in here. So remember, review num1 and num2 are parameters. We know that. We create a variable number1 equals 5, number 2 equals 6. We call the function 5, 6. However, we want to make a subtle change in our program. We want to change num1 to 10 in the function. We run it, and the value is 60. However, number 1, because we change, so 10 times 6 is 60, that's why we get 60. However, number 1's value, and to point that out or to see that, is still 5. So we run it, 65. So what happens is num1, this is what I wanted to show you. Num2, still the same. So what happens here is we use number 1 and number 2 as arguments. They come in here. Number 1 points to the value 5, but once we change it, then num1 points to the value 10. However, number 1 is still pointing to the value 5, and thus we get 60 and 5. And that's what I wanted to cover as far as void functions go.